The movements and muscles of the wrist and hand. So we begin with our wrists, which is the articulation between the distal radius and the first row of carpal bones, specifically scaphoid and lunate. We have the opportunity to do flexion, extension, and then our deviations ulnarly and radially. The muscles that control the wrist are located in the forearm and most often are originating from down at the epicondyles. On the anterior surface, the medial epicondyle controls the muscles that cause flexion in the wrist and actually most of the fingers as well. So we come up here, we're going to see flexor carpi radialis, flexor carpi ulnaris here in this pattern. In the center, that not everyone has, is a palmaris longus tendon that is evident by its existence outside of the transverse carpal ligament. And what we do with these three, all three together cause flexion. Individually, each will cause flexion, but the flexor carpi radialis will also cause radial deviation, and flexor carpi ulnaris will also cause ulnar deviation. You can see that guy right there as he pops through the pisiform. On the extensor side, it's very similar. We're also having three sets of muscles that are going to cause extension. So right here, you can see extensor carpi ulnaris. These, of course, are coming from the lateral epicondyle. And then we have two on the extensor carpi radialis side, a longus and a brevis. The longus is going to be the one that actually does the radial deviation on this side. The brevis is too short to cause that deviation. So, in going in ulnar deviation, we actually see antagonistic muscles cooperate. Extensor carpi ulnaris and flexor carpi ulnaris both cause ulnar deviation. In radial deviation, it'll be the job of extensor carpi radialis longus and flexor carpi radialis. And that leaves you one extra muscle on each side that will just do the flexion or extension, palmaris longus and extensor carpi radialis brevis. For gross motion of the hand, now first we should identify that we have 5 digits, 1, 2, 3, 4, 5, 1 thumb and 4 fingers. If we're using a muscle that is going to control the thumb, you'll see the word pollicis in it. Also, the word thenar is associated with this thumb, which is this set of musculature right here in the palm. Hypothenar belongs to the little side of the hand, or the ulnar side, and digiti minimi is the name of the small digit. So we have hypothenar and a thenar eminences, here and here, and pollicis and digiti minimi. Now in the middle, all 4 of these will be referred to as digitorum. So a muscle that has the name digitorum will control all 4 digits. And then the last one is named individually as indicis, or index finger. So the gross motions available are finger flexion. We'll save the thumb for later. He's got a lot of stuff going on separate. So finger flexion and finger extension to begin with. On the flexor side, we have a very similar pattern of coming out of the medial epicondyle, climbing up the entire forearm, reaching up and grabbing the fingertips. The 2 muscles here are called flexor digitorum superficialis, which is on top, and flexor digitorum profundus, which lays beneath. The difference in them functionally is that profundus extends all the way to the tip. So you can see in this guy right there. Flexor digitorum superficialis splits in a Y shape here at the proximal interphalangeal joint. So it allows the PIP to flex, but not the IP joint. So the best way to demonstrate this is if you have your fingers flat and you pull your finger into flexion, you're unable to control that distal joint unless you add all the fingers in, and then we're able to curl fully. That shows the isolation of just the flexor digitorum superficialis in action. Profundus does the tips. And they all follow through the carpal tunnel canal in here. On the extensor side, extensor digitorum covers the whole back of the hand, coming from, again, the lateral epicondyle, climbing up, and allowing all the fingers to extend together, all joints. We have an extensor hood mechanism that allows all the joints to move as one. The indicis and the digiti minimi each have their own extensor. So extensor minimi and extensor indicis are separate to allow these two guys to operate separately. Another way to check how we're lined up is if we lay our finger down like this and try to lift the ring finger by itself. He can't operate without assistance from his friends. So these guys will share a common tendon going down. Extensor digitorum is also sometimes called extensor digitorum communis, meaning communal. So you might say EDC or ED. And on one of the sheets I showed you, I used just the abbreviations of the muscles that will help you study them rather than having to write them all out. We also have a pollicis flexor that is on the anterior surface of the hand. It slides up through the carpal tunnel and makes its way up to the tip of the thumb. To describe the motions of the thumb first, to make sure we know we're all talking the same language, we have thumb flexion that pulls it in, thumb extension that sticks it out, like that. Thumb abduction goes this way, out and away from the hand. And I think of the B in abduction for B for bowling, that's how you would grasp a bowling ball. And then for adduction pulls it back in again. The thumb also at the CMC joint has, all of these are CMC joint motions by the way, but at the CMC joint has the ability to oppose, and that looks like this. It's an arc across touching the base or tip of the fifth digit. The difference between flexion, when you can see all of my thumbnail looking at you, and opposition is that subtle arc that we add in. There's different muscles that do that, of course. The other joints of the thumb, the MCP and the IP, can only flex and extend. They just have the ability to work as hinges, as do the PIP and DIP of all the digits. These work as hinges. However, the MCP of the fingers, we'll see later, is a condyloid joint, so I can also ab and adduct and circumduct from there. I can circumduct at the thumb, but that's coming from the CMC. All exciting motions in the thumb are coming from down here, and often manifested as wrist pain when they're really overuse of the thumb joint. So the last of the what we call extrinsic muscles, and by that we mean muscles that come from outside of the hand and climb up and in. So we have the extrinsic flexors, flexor digitorum, superficialis, and profundus, the three extrinsic extensors for communis, indicis, and digiti minimi, and then the last of this batch is flexor pollicis longus. It makes it all the way to the tip of the thumb and allows you to curl the entire thumb in. When you see a muscle with the word longus on the end, we'll soon be meeting one with the word brevis on the end. Brevis is a Latin word for short, so longus versus brevis we'll be waiting for him. He's in the intrinsic part of the hand up here. The last part of the extrinsics involves thumb-only motions over here. And the thumb motions come through an area that we refer to as the anatomical snuff box. In that snuff box, if you push your finger in there deep enough, you'll feel the CMC joint itself, and therefore the carpal bone trapezium. This motion here, extension and abduction, are pulling from down on the mid-forearm, and again are extrinsic muscles. So this first one you see here is extensor pollicis longus. It goes all the way to the tip. You can almost see my tendon sticking out there. Extensor pollicis brevis is next door over here. He stops short, so he does this, but not that. So extensor pollicis brevis, extensor pollicis longus. Then abductor pollicis is over here. So you'll see him shooting out that way. So abductor pollicis longus is right there. So you've got a longus, an extensor, a brevis, an extensor, and then a longus, an abductor. And those are all the extrinsics. There are 9 in total. I like to numerate things. So I've got 3 here, 3 for the snuff box, 3 for extensor. Let's not forget our 6 wrist muscles that we already did. And now there's only 10 more to go. The 10 intrinsic muscles are all found here. We've got 3 in the thenar eminence, 3 in the hypothenar eminence, and then 4 groups, actually quite a few more actual muscles, within the deep palm. So starting with the thenar eminence. The muscles we haven't seen action from yet are flexor pollicis brevis, which is this meat right here, allows my thumb to come in here, and it flexes the CMC, MCP only. The IP joint is only flexed if I kick in flexor pollicis longus, like that. So flexor pollicis brevis does that. Abductor pollicis brevis does that. Now, abduction only occurs at the CMC joint, so abductor pollicis longus and brevis are only separated in how long their tendon is. So abductor pollicis longus goes all the way down here. Abductor pollicis brevis is right here on the outskirts lateral aspect of your thumb, right here. And then the third guy is opponens pollicis. Opponens pollicis allows us to oppose, so he's pulling up and over to meet at the base of the thumb. So these are the three thenar eminence muscles, what we call the fine motor component of the hand. You'll get into this in future classes, but the radial side of the hand is more for precision, and our ulnar side of the hand is more for gross grasp. So you'll watch developmentally we go gross first, and then later translate to fine. On the hypothenar side, we have the exact same three muscles, but instead of pollicis, we see digiti minimi. So there's a flexor digiti minimi, no need for a longus or brevis because there is only one. An abductor digiti minimi sticks you out that way. Again, no need for a last name. He's got three names already. And an opponens digiti minimi, which pulls you back in to meet your thumb. So they're all over here in this quad. Those are our two main arches of the hand are formed out of that group of musculature. When we say a hand is flattened or unable to roll into a good fist like this, we're missing some musculature in here, often from nerve damage or simply the hand hasn't developed yet. That leaves us in here for the deep palm to wrap up. So we haven't seen yet is how we abduct and adduct our fingers. I leave the thumb out of this again because what happens is abduction of the thumb goes that way, but the fingers go that way. So leave him out for the moment. If your middle finger is the center of your hand, you're going to either adduct toward it or abduct away from it. We can also leave this guy out because we already did the abductor on the digiti minimi. So with just these three fingers, we see we can abduct and adduct toward. Abduction away is the job of the dorsal interossei, which are located here, 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 another one, and one there. So they're deep here underneath the tendons, and now you know that these tendons are our extensor digitorum, extensor indicis, and extensor digiti minimi. And again, they've come all the way up from the forearm to do their job. So those interossei, which literally means between the bones, they're in here, help spread the fingers. On the palmar side, we have interossei that will adduct the fingers. So we've got one here, and one here. They pull them together. The ring finger being the center doesn't adduct on itself unless he's already abducted. So he goes out and he comes back in from his other abductor. So don't worry about all the specifics there, how many there are, and where they are. The acronym I used to remember is PAD, palmars adduct, DAB, dorsals abduct. And those are the interossei. We've left off this big guy here we call the web space. He's a very large muscle here. This guy is called adductor pollicis, and as his name implies, he snaps the thumb back to the index finger. So he's down here in abduction. There he goes. You can feel that tension in there. That leaves us one last muscle group. They are here, called the lumbricals. And the lumbricals, oh, there you can see adductor pollicis in his glory. The lumbricals allow our hand to do this. This is an action that shouldn't happen by the rules of flexion and extension coming from the extrinsic muscles. So what the lumbricals do is they bridge the gap between the flexor and extensor tendons and allow our hand to form this position. It's described as flexion at the MCP joints, extension at the IPs. So both the PIPs and DIPs are extended. This hand position, along with the thumb coming in, is known as the intrinsic position, where my intrinsics are intact. The opposite of that, which is a good stretch for the intrinsics, but is also indicative of a nerve problem where the hand is damaged, this look here. So this is called the intrinsic minus position. Intrinsic is not working. Those are your hands. Enjoy them, love them, and if you have any questions, be sure to email me. See you on the other side.